Bismillahirrahmanirrahim. New syllabus Physics SSC 1, Unit number 2, Kinematics, Exercise 2, Numerical Problem 2.6 to 2.10. In previous video, we solved 2.1 to 2.5. Now we will solve 2.6 to 2.10. Now in question number 6. Drive a train from a rest with an acceleration of 0.5 meter per second. Find its speed in kilometer per hour when it moves through a 100 meter. When it is has moved through 100 meter. First of all, we write the given data. Initial velocity, it starts from a rest. So, initial velocity Vi is equal to 0 meter per second. And acceleration given that 0.5 meter per second square. Then acceleration A is equal to 0.5 meter per second square. Distance S is equal to 100 meter. So, distance S is equal to 100 meter. To find final velocity Vf, formula third equation of motion 2as is equal to Vf square minus Vi square. Solution, putting the value in this formula, then 2as is equal to Vf square minus Vi square. Then in above equation 2a is 0.5 multiplied by s 100 is equal to Vf square minus initial velocity 0 square. Then we multiplying the 2 multiplied by 0.5 multiplied by 100. That answer is equal to 100 is equal to Vf square minus 0. Then answer is 100 Vf square. Then taking square root on both sides, Vf is equal to 10. Now final velocity Vf is equal to 10 meter per second. Vf is equal to, now convert the answer 10 meter per second into kilometer per hour, then convert into hour, 1 hour 3600 seconds and 1 kilo is equal to 1000. Then Vf is equal to 10 multiplied by 3600 divided by 1000. Then final answer is Vf is equal to 36 kilometer per hour. Result, the final velocity in kilometer per hour is 36 kilometer per hour. In question number 7, a train starts from a rest, accelerate uniform and attain the velocity of 48 kilometer per hour in 2 minutes. It travels at a speed of 5 minutes. Finally, it moves with a uniform retardation and it stops after 3 minutes. Find the distance traveled by a train. First of all, we draw a trapezium. Then we solve this numerical. Solution, total distance traveled C in trapezium OABC, then total distance traveled is equal to area under the graph of trapezium OABC. Then we have area of trapezium S is equal to distance, then it is denoted by S. So S is equal to 1 upon 2 sum of parallel side multiplied by 5 is equal to 1 upon 2 OC plus AC multiplied by AD. Then final answer S is equal to 1 upon 2 into 10 upon 60 plus 5 upon 60 multiplied by height, thus is equal to 48 kilometer per hour. Then final answer is equal to 6 kilometer Now distance is equal to 1 kilo is equal to 1000. Then distance S is equal to 6 multiplied by 1000. That is equal to 6000 meters. Now the result is total distance traveled by a train is 6000 meters. In question number 8, a cricket ball is hit vertically upward and returns to its ground 6 seconds later. Calculate the maximum height to reach the ball and initial velocity of a ball. Then first we calculate the initial velocity of a ball. We write the given data at a maximum height. Vf is equal to 0 and time will be half to reach the maximum height. T is equal to 3 seconds. Now body moves to upward, then gravitational acceleration and its value is minus 10. So G is equal to minus 10 meter per second square. Now to find the final velocity Vf, then we write Vf is equal to Vi plus Gt. Then putting the value in first equation of motion Vf is equal to Vi plus 180. Now putting the values in above equation Vf is equal to 0 is equal to initial velocity Vi plus A is equal to G. Then we put that minus 10 multiplied by 3 is equal to 0 is equal to Vi minus 10 3s are 30. Then initial velocity is 30 meter per second. Result, the required initial velocity of a ball is 30 meters per second. Now we calculate the maximum height reach the ball. Then we have right given data initial velocity to find. Now this value is Vi is equal to 30 meter per second and time T is equal to 3 seconds. Value of G is minus 10 meter per second square and Vf is equal to 0. To find H, then we use the second equation of motion. We replace S by H and A by G. Then H is equal to VIT plus 1 upon 2 GT square. Putting the values in above formula to find the solution, H is equal to VI 30 multiplied by time T3 plus value of G minus 10 and 3 square. So H is equal to 90 plus 1 upon 2 into minus 90. Minus 90 divided by 2 is minus 40, then H is equal to 90 minus 40 is equal to 40 meter. So the final result at a maximum height the ball reached is 40 meter. Now in question number 9, when brakes are applied, the speed of train is decreased from 96 km per hour to 48 km per hour in 8 meters. How further will the train move before coming to rest, assuming the acceleration to be a constant? Now, write the given data Vi. Initial velocity is 96 km per hour. That convert into meter per second. So, kilometer is kilo is equal to 1000 and per hour is 3600 seconds. Now 96 multiplied by 1000 divided by 3600 meter per second. The final answer of initial velocity is 26.6 meter per second. And now we write the final velocity Vf is equal to 48 kilometer per hour. Similarly, we can change this value in meter per second. 1 kilo is equal to 1000 and 1 hour is equal to 3600 seconds. So we can convert the values and find the S1 formula. Using the third equation of motion, 2a(s1) is equal to vf square minus vi square. Putting the values in this equation, then we have 2a(s1) is equal to vf square minus vi square. That is 2a into 800 is equal to 13 point. Here we write 13.033 whole square minus 26.06 whole square. The final answer is 8 multiplied by 2 is equal to 1600a and 13.033 square is 177.69 and 26.0 second square is 707.56. Now we write the answer is 1600a is equal to minus 529.8. 1600 here divided, so a is equal to minus 0.333 meter per second square. Now we find the distance S2. Putting the values in this equation, 2as1 is equal to vf square minus vi square. Here S1 we write S2, then minus 2. Putting the value of a minus 0.33 into S2 is equal to, final velocity will be 0. So 0 square minus 13.33 square, we find the answer is S2 is equal to 266.66 meter. So the required distance by the train move before coming to rest is 266.66 meter. In last numerical, question number 10, in the above problem, find the time taken by the train stop after application of brake. Now, given data Vi is equal to 26.66 meter per second and Vf is equal to 0 meter per second. Then we write S is equal to 800 plus 266.78. Then final answer of A is equal to 0.33 meter per second square. Now to find the time, then we have, so using the equation number 1, Vf is equal to Vi plus At. Putting the values to find the solution, Vf is equal to Vi plus At. Then we know that Vf is equal to 0 is equal to Vi 26.66 plus value of A minus 0.333 multiplied by T. 0 is equal to 26.66 minus 0.333 into T. Then we move this value in other side. T is equal to minus 26.66 is equal to minus 0.33 T. Minus cancel out by minus and this value divided is here. So T is equal to 80 seconds. The result, the total time taken by a train to stop after application of brake, then 80 seconds. Okay, beta. Thank you. Best of luck. Allah Hafiz.